Hey everyone, welcome back. So this is our day 37 of 365 days of coding, and today we're gonna solve a problem which is related to COVID-19, right? So imagine that we are living in a city where we are dealing a certain number of COVID-19 cases every day, okay? And we want to figure out how many days it will take for these cases to reach zero, okay, based on some parameter which are given, and that's what exactly we need to do in this problem. So you can pause this video to read out this problem, and let's move to our understanding of this problem. So basically, first we need to understand some terms before we start writing the code. Okay, so first understand this. So given that the average number of cases recovered per day is represented by A, then the number of new cases per day is represented by B, and the current active cases is represented by C. Okay, now our task is to find the minimum number of days we need to check if the total active cases are reached to zero or not. Now let's see how we gonna solve this problem. So this is a plain English approach, and then we will convert it into a program. So basically our approach gonna be, first we will try to calculate the net increase or decrease in active cases per day. Okay, now we will update the current active cases based on our daily changes. Okay, now we gonna keep on repeating this step and 2 until the current active cases become 0. And so if these steps are repeating, in that scenario we need to use a loop, right? So this is evident with this thing. Okay, now finally we will keep track of number of days passed, and then we will print those days. Okay, so let's write a code so you will get a better understanding, but my approach gonna be to solve this, and you can also pause the video and try out your way to solve this. Okay, so we have wrote our approach. So basically what we are doing here, first we are taking the user input, and note that we are having these 3 inputs which we are taking from the user, and where this A basically represents the average cases recovered per day, B will represent the new cases per day, and C tell us the current active cases. So with this we will provide these values to this minimum days to 0 function, and this is our function. So what we are doing, we need to figure out how many days, minimum days it will take to get total number of cases to reach to 0. Okay, that's why we are initializing this variable, and the current count is 0, let's say. Now how we are solving this problem? So basically we are using this loop, okay, to simulate each day's activity until we are reaching to 0. Okay, so what we are doing is we are calculating the total cases, okay, each day. So what we are doing for that, we are doing current active cases plus new cases. So this will give us the total cases, and then we update the current active cases by subtracting reverse. So here you can see we have subtracted the recovered cases, okay, from the current active cases. So current active is this total cases minus A, okay, which is basically the recovered cases. Okay, so whatever be the max of it, we are printing it over in the C. So let's say this is 0, here we get 2, 3, 4, so that is greater than 0, right? So until we reach less than 0, so we will get that value only, and if let's say our cases reach still negative value, so we will get 0. This is clear, I guess. So for each iteration we are doing, so we are increasing the days to by 1. So let's say first time we didn't reach to 0, right, till 0. So we have passed 1 day, then second day will arrive, then third day will arrive, and at the end the days will get returned. Okay, that's what we are doing here. So these days will keep track of how many days are passed till the cases reach to 0. So I hope you understood this, what we are doing here. So let's run this and see how this solution approach is working. Okay, so if we see the input, so it is 5, 3 and 1, and the output is 1. So 5, then 3, and then 1. and we are getting 1 as output, which is correct. Now let's check another input. 4, 3 and 2, output is 2. So 4, then 3 and then 2, and we are getting 2 as output. So this program is working fine. Now let's see how we can optimize this solution. Okay, so what we can do in optimization, so we can, instead of looping through, what we can do, we can directly calculate the minimum number of days to reach 0 cases based on the net decrease per day. Okay, so let's write the code. This is our optimized solution. Okay, now in this optimized solution we are still using those same 3 inputs that are A, B and C over here. Okay, and they basically represent the same thing. A represent the average cases, B represent the new cases, and C represent the current active cases. Okay, and the goal is again same. We need to find the days till we reach 0. So here in this optimized solution, but our focus is to determine the net decrease in active cases per day. Okay, how we are calculating that? So to calculate that, what we are doing, we are subtracting the new cases B from the current recovered cases, that is A. Okay, once we do this subtraction, then we get the net decrease per day. Instead of simulating each activity through a loop, okay, we directly calculate the minimum number of days needed to reach 0 cases. Now here you can see this is basically the formula which we are using here. First we added C, which is current active cases, to the net decrease per day, which we found here. Now this will basically tell us the total number of cases that reduce after 1 day. Then we subtract 1 from this total, because even if the net decrease doesn't fully eliminate it, the current active cases count is still a day. Okay, and then finally we are driving this total by net decreasing per day. So this gives us the number of times the net decrease, means the net decrease per day is basically fits in this total reduction or not. So now we also use this double slash, if you see. So it is basically an integer division which ensure that we get a whole number of days, and it will basically round up if necessary, and then in this return the result. Okay, so whatever be the result, so we get that. So whatever be the maximum value, say this part is the maximum, so that will return. Not this part is maximum, then it is return. Otherwise one will get return. Okay, because see, 1 day is needed, so 1 day is by default required, right, to reach till 0 cases. Basically in this optimized solution, what we are trying to do, we are trying to avoid the need of a loop, and we are trying to figure out the minimum number of days directly based on the net decrease of active cases per day. Okay, so let's see if this solution is even works or not. Let's run this. Oh, okay. Okay, so let's run this, and first we will go here. So our input was 5, 3 and 1, output is 1. 5, then 3, then 1, output is 1. And let's see, 4, 3 and 2, output is 2. 4, 3, 2. The output we are getting is 2. And you have it. We have solved the problem of determining the minimum number of days to reach 0 COVID-19 cases in a city, and I hope this explanation will be helpful for you. And with this, do not forget to like, comment and subscribe for more Python programming content. See you in the next video.